Welcome everyone to our new topic today, indices. We shall be taking this topic from our page 69 of hidden facts in JSSCE mathematics. Laws of indices. X raised to power 0 is equals to 1. Any number raised to power 0 is 1. This is true in all situations. Let's take a few examples to illustrate this law. Number 1, 2 raised to power 0 is equals to 1. Number 2, 100 raised to power 0 is equals to 1. Number 3, bracket open, 1 over 4 raised to power 0. We close the bracket, raised to power 0 is equals to 1. Number 4, we open our bracket, 16 raised to power 2 plus 1 over 2, bracket close, raised to power 0 is equals to 1. Now let's take another law. X raised to power minus a is equals to 1 over x raised to power a. Let's take some few examples under this. The example will not be totally solved. So let's take example 1. 4 raised to power minus 2 is equals to 1 over 4 raised to power 2. Application only. Example 2. 5 raised to power minus 3 is equals to 1 over 5 raised to power 3. Application only. Why we stated application only is that we are not solving the problem fully. We are only trying to explain how the law works. Let's take another law. Bracket open, x over y, bracket close, raised to power minus a is equals to, bracket open, y over x raised to power, you close your bracket, raised to power a. The law is this, that anytime you have a fraction raised to power of minus any number, that fraction is now reversed. Denominator become numerator when you are changing it to the real power it is raised to without the minus. Let's take a simple example to illustrate that. Example 1. 3 over 2, then we close our bracket, raised to power minus 2 is equals to 2 over 3. We open and close our bracket, raised to power 2. Application only. Example 2. 15 over 14. Open and close bracket, raised to power minus 2, raised to power minus 3 is equals to 14 over 15. Bracket open and close, raised to power 3. Another law. Multiplication is addition of powers. Let's take the law. X raised to power a times x raised to power b times x raised to power c is equals to x raised to power a plus b plus c. Let's take simple example to express the law. Example 1. 2 raised to power 3 times 2 raised to power 2 times 2 raised to power 1 is equals to 2 raised to power 3 plus 2 plus 1, all in the powers. Application only. Example number 2. 4 raised to power 4 times 4 raised to power 1 times 4 raised to power minus 2 is equals to 4 raised to power 4 plus 1 plus, then you open your bracket and put minus 2. You close your bracket. Example 3. 2 raised to power 4 times 2 raised to power 1 is equals to 2 raised to power 4 plus 1. Counter examples. Example 1. 2 raised to power 4 times 3 raised to power 2 times 2 raised to power 1 is not equals to 2 raised to power 4 plus 2 plus 1. This is not possible since 3 is not a base 2 number. It's not in the same base with 2. It's not in the same base with 2. Let's take another example, counter example. 5 raised to power 2 times 4 raised to power 2 times 5 raised to power 1 is not equals to 5 raised to power 2 plus 2 plus 1. This is not possible since 4 is not in the same base as 5. Other examples in between. Let's take example 1. 2 raised to power 1 times 6 raised to power 3 times 3 raised to power 2 is equals to 2 raised to power 1 times, bracket open, 2 times 3, bracket close, raised to power 3 times 3 raised to power 2. Here we expanded 6 as 2 times 3 in line with other base. Now we now have our result as equals to 2 raised to power 1 times 2 raised to power 3 times 3 raised to power 3 times 3 raised to power 2. We can confidently work with similar bases now. 2 and 3 is what we are having here. So we now have 2, which is equals to 2 raised to power 1 plus 3 times 3 raised to power 3 plus 2, which will give us our result as 2 raised to power 4 times 3 raised to power 5. This is application only, will stop there. Another law. Division is subtraction of powers. X raised to power A divided by x raised to power B is equals to x raised to power A minus B. Let's take a few examples to illustrate the law. Example 1. 2 raised to power 4 divided by 2 raised to power 2 is equals to 2 raised to power 4 minus 2. Let's take another example. 3 raised to power minus 3 divided by 3 raised to power 2 is equals to 3 raised to power minus 3 minus 2, which is equals to 3 raised to power minus 5. Take note of that example. The first power was minus before we introduce the one that has to do with the law. Let's take another example. 2 raised to power minus 6 divided by 2 raised to power minus 2 is equals to 2 raised to power minus 6 minus, then bracket open, minus 2 before we close our bracket. And that will be equals to 2 raised to power minus 6 plus 2. When our bracket open, the minus become plus. Minus times minus become plus. And that will give us our result as 2 raised to power minus 4. We are treating another law now. Fractional powers is root according to the denominator. Let's look at the first simplified part of the law. X raised to power 1 over 2 is equals to root x. Example, 4 raised to power 1 over 2 is equals to square root of 4. Here it is square root. Let's take another simplified part of the law. X raised to power 1 over 3 is equals to cube root of x. Now, simple example by the side. 8 raised to power 1 over 3 is equals to cube root of 8. We take another simplified form of the law. X raised to power 2 over 3 is equals to, bracket open, cube root of x, bracket close, square. Example of that, 27 raised to power 2 over 3 is equals to bracket open, cube root of 27 square. Another simplified form of the law. X raised to power 1 over 4 is equals to 4th root of x. Simple example. 16 raised to power 1 over 4 is equals to 4th root of 16. From C, we can see clearly that root is taken according to the denominator. So in general, x raised to power a over b is equals to bracket open b root of x raised to power a, where b is the denominator of the fractional power. Example 1. Simplify a raised to power 3, b raised to power 4, c raised to power 7 all over a raised to power 2, b raised to power 6, c raised to power 7. The options are given. A over b square, b square over a, c a square over b, d a over c, e 1 over b square. Solution. We operate indices of each base letter accordingly. Thus, a raised to power 3, b raised to power 4, c raised to power 7 all over a square, b raised to power 6, c raised to power 7 will be equals to a will now be raised to power 3 minus 2, knowing that a up is raised to power 3 and a down is raised to power 2. Then b will be raised to power 4 minus 6, knowing that in the numerator we have 4 and denominator we have 6. Hence, that difference there. C will be raised to power 7 minus 7. C has power of 7 at the numerator and also have power of 7 at the denominator. And this is equals to, we are now subtracting the powers. In case of A, it will be raised to power 1. In case of B, 4 minus 2, 4 minus 6 will give you minus 2. In case of C, 7 minus 7 will be equals to 0. So C will be raised to power 0. Recall that x raised to power 0 is equals to 1. And b raised to power minus 2 is equals to 1 over b squared. So our answer will become a over b squared. Another example. Bracket open, a raised to power 2 times b raised to power 5. Bracket close. Divided, bracket open, a raised to power 3 times b raised to power 4. Bracket close. Equals option A, b raised to power minus 1. Option B, a raised to power minus 1b. Option C, a raised to power 5 times b raised to power 9. Option D, AB. Solution. The problem we are given is the same as a raised to power 2 times b raised to power 5 all over a raised to power 3 b raised to power 4, which is equals to a raised to power 2 minus 3. Since the power of a at the numerator is 2 and power of a at the denominator is 3, so we subtract it. Then times b raised to power 5 minus 4. The same apply, which is equals to a raised to power minus 1 times b. Another example. Calculate the value of 2 raised to power 3 times 3 raised to power 2. A, 36, B, 48, C, 54, D, 72. Solution. 2 raised to power 3 times 3 raised to power 2 is equals to 8 times 9. This is so because we cannot add indices, that is powers in bracket, if they are not in the same base. So our result is equals to 72. Another example. Solve y raised to power 3 times y raised to power 2 times y raised to power 5. Options. A, 30. B, y raised to power 10. C, y raised to power 30. D, y raised to power 0. E, y raised to power 4. Solution. Since our problem are in the same base y, we can add the powers. Thus, y raised to power 3 times y raised to power 2 times y raised to power 5 is equals to y raised to power 3 plus 2 plus 5, which is equals to y raised to power 10. Another example. 20a raised to power 3 times b raised to power 5 divided by 5a square b cube. A, 4ab square. B, 4a square b square. C, 4a square b cube. D, 4a square b raised to power 4. E, 4a cube b raised to power 5. Solution. 20a cube b raised to power 5 divided by 5a square b cube is equals to 20a cube b raised to power 5 as the numerator of the fraction divided by 5a square b cube. Next, we divide the numbers as usual. Then we apply indices rule to the powers of a and b, which is equals to, we have 20 divided by 5 will give you 4. So you have 4 times a raised to power 3 minus 2 as b raised to power 5 minus 3, which is equals to 4a raised to power 1 b raised to power 2, which is equals to 4ab squared. Another example. Simplify x raised to power 2 times 4x raised to power 5 divided by 2x cubed. Options. A, 2x raised to power 4. B, 4x raised to power 3. C, 5x raised to power 3. D, 7x raised to power 4. E, 11x raised to power 3. Solution. X squared times 4x raised to power 5 divided by 2x raised to power 3 is equals to, we are taking fraction now, the numerator x raised to power 2 times 4x raised to power 5 divided by 2x cubed. We divide numbers as usual, then apply indices rule to the powers of x. Expressing it properly, we will have 4x raised to power 2 plus 5 in fraction form. Then that will be 2x raised to power 3, which is equals to 2x raised to power 7 minus 3, which is equals to 2x raised to power 4. Another example. Evaluate 64 raised to power 2 over 3, A, 16, B, 9, C, 25, D, 36, E, 27. Solution. Applying the rule of indices, 64 raised to power 2 over 3 is equals to, open up a big bracket, open another smaller bracket within, you have 64 raised to power, you close your small bracket and raised to power 1 over 3. Closing our bigger bracket, raised to power 2. Or we express it this way. We open our bracket, that will be 64 cube root square. Recall that in indices, fractions are roots. So we are talking about cube root of 64 will give you 4. And we have open up our bracket and square it. That is equals to 16. We've come to the first part of our examples under this subtopic. We take some exercises taken from page 71 and 72 of our JSSCE in Hindi mathematics book. Try your hands on the exercises and check out the answers at the last part of the book, either in the soft copy or the hard copy. Thank you.